Alright guys, so the final lesson in this module is we're going to be talking about a system of equations. So in Algebra 1, you learned how to solve a system of two, and so in this one we're going to actually look at when I have three variables. We're also going to talk about solving a system of linear and nonlinear equations, but we're going to use it graphically. So you're going to need to use that calculator, and we're going to want that calculator be comfortable with those functions that we've been using. Alright, so for this first problem, I want you to just pause the video. I want you to look at the given information. An ice cream, a cupcake, and an ice cream is $12.75. An ice cream, a donut, and an ice cream is $10.50. What do you think each treat costs? So go ahead and just do some problem solving. Alright, so we're going to revisit this problem in class tomorrow. But I'd like to see, what do you think an ice cream, a cupcake, and a donut is worth? So when I approach word problems, I always use these questions. These are kind of my thinking process. So first of all, I always go to what the question is asking, because that's going to tell me what my variables are. That's going to define my variable. What equations can I write? So I'm going to use my given information that's in the text to write that equation. And then we're going to use what's called a matrix. And so this is a calculator function. If you are unfamiliar with how to use that function, I've made a video on that handout. You scan that QR code and it'll show you how to type it into the calculator. And then what are the solutions? So once I use that matrix function, what are the solutions? And I want them in context. So not just 3, 4, 5 or x equals 2, y equals 3. I want, what does that mean in context? So put it back in the context of the problem. Alright, so here is my first problem. So I'm always going to mark up my text and pick out my important information. So I know that 3 orders are placed at a pizza shop. 2 small pizzas, a liter of soda, and a salad cost $14. So 2 pizzas, a liter of soda, and a salad cost $14. I also know that 1 small pizza, a liter of soda, and 3 salads cost $15. And then 3 small pizzas, a liter of soda, and 2 salads cost $22. And my question is asking, how much does each item cost? So the first thing I ask is, what is the question asking? So the question is asking, how much does each item cost? So how many items do I have in each of these scenarios? I have a pizza, I have soda, and I have a salad. So the first thing I need to do is I need to define my variables. Alright, so I always want to say what it is in context. I don't just want to write pizza, soda, salad, because there's 2 things going on here. I have the cost of it, and then I have the number of those items. So sometimes it will ask you, it'll give you the cost of everything and ask you for how many. So we always want to say, what is it in terms of that question? So I'm going to say that X is the cost of a pizza, Y is the cost of a soda, and Z is the cost of a salad. So I'm always looking for, what are my variables? So now that I've defined those, what equations can I write? Well, I'm going to go ahead and take X, and I'm going to put it anywhere I see pizza. So 2X's there, 1X there, oops, that's an X, 3X's there. So then the cost of a soda, so I have a soda here, I have a soda here, and I have a soda here. And then I have a salad here, I have a salad here, and I have a salad here. So what equations can I write? So I'm basically just going to put those 3 equations together. Alright, so I was able to say that 2x plus y plus z equals 14, and that represents what's happening in the blue. Then I had 1x, 1y, and 3 z's, and that gave me 15. And then I had 3 x's, 1 y, and 2 z's, gave me 22. So now that I've written my equations, I'm going to go to my calculator and I'm going to use that matrix function. So the first thing, that in order to use the matrix function, it always has to be in standard form. So standard form is where I have all of the same variables aligned, and if I don't have a variable, I've put a 0 in for it, and they all equal a constant. So either that constant is a whole number, or it could be 0 if I have to set it equal to 0. But this is the format that I always need. So now I can go to my equation, or I'm sorry, I can go to my calculator and use that matrix function. So I'm going to do that right now. All right, so I went to my matrix. I made A be a 3 by 3, and so I put in the coefficients going across 2, 1, 1, 1, 1, 3, 3, 1, 2. And then I edited matrix B, and I made it my constants, so 3 by 1, so 14, 15, and 22. And then I did the A inverse B, and I ended up with x equals 5, y equals 1, and z equals 3. And so what does that solution mean in context? So coming all together, that means that a pizza costs $5, a liter of soda costs $1, and a salad costs $3. I can go back to, and that's why defining my variable at the end is so easy. I simply say 5 is the cost of a pizza, 1 is the cost of a soda, 3 is the cost of a salad. And I can always go back and check. 2 times 5 plus 1 plus 3, does that give me 14? 5 plus 1 plus 9, because it's 3 salads at $3 each, does that give me 15? And 3 pizzas, so 3 times 5 plus 1 plus 6, which would be 2 Z's, does that give me 22? All right, so here's another system of equations. It's not going to be as straightforward as that previous example, so we're going to have to do a little manipulating, but we're going to go through that same process. So first I need to identify, I just need to read through it. So an electronic repair shop offers 3 services: on-site, at home, and by mail. So on-site, at home, and by mail. So the on-site service costs 3 times as much as the at-store service. The by mail service costs $10 less than the at-store service. All right, so last week the shop completed 15 services on-site, 40 services at-store, and 5 services by mail, for a total of $2,650. And so our job, what is the question asking? We need to find the cost, so that's going to be my variables, of each repair service. That's what I'm solving for. So what is the question asking? I need to know the cost of on-site, the cost of at-store, and the cost of by mail. So what are my variables? I'm simply going to define those. All right, you can use any variable if you wanted to use like site, whatever variable you want to use, but I just like to use x and y's and z's. So x is the cost, because that's what we're looking for, of the on-site, y is the cost of the at-store, and z is the cost of by mail. All right, so now that I've identified my variables, what equations can I write? So I'm going to go back and I'm going to put my variables where they go. So the on-site service. So I know that on-site is right here, and it's going to cost 3 times as much as the at-store, which the at-store is y, and then by mail is z, and it's going to cost $10 less than at-store, which is y, and then here's x, at-store, on-site, at-store, by mail. And then I just see this total, so I got to think about this. All right, so here's where some people get a little confused, is being able to put these equations together. But if you step back and just think about what the words are saying, it's going to be a lot easier. All right, so let's start with on-site. So on-site costs 3 times as much as at-store. So if the on-site was 30, it's 3 times as much as the at-store, so the at-store would have to be 10. So in order to set x and y equal, because we're writing equations, so in order for me to say that on-site is equal to at-store, they're not equal. The on-site is worth more. So I'm going to have to multiply the at-store by 3 in order to set them equal. So I'm going to start with setting them equal. On-site equals at-store. I know that the on-site is worth more, so in order for them to be equal, I need to take that y and multiply it by 3. So the first equation that's going to represent this sentence right here, on-site is 3 times as much as at-store, is going to be x equals 3y. All right, now we need to look at by mail. So by mail costs 10 less than at store. So by mail is $10 less than at store. So by mail is going to be less than at store. So let's start with setting them equal. So right now I'm saying that at store and by mail are equal. But I know that the by mail is $10 less than the at store. So in order to set them equal, so if the at store was 40 and the by mail is $10 less, I would have to subtract 10 from that value. So I'm going to subtract 10 from the at store service. So my equation is going to be y minus 10 equals z, or z equals y minus 10, however you want to write that. All right, so last week the shop completed 15 on-site, 40 at store, and 5 by mail, and they made a total of $2,650. So what I'm doing is to find how much they made off of the on-site services, I'm going to have to take 15 times x, because x is the cost, and then 40 times y will tell me how much they made at store, and then 5 times z will tell me how much they made by mail, and that's going to give me a total of this. So my equation is going to be 15x plus 40y plus 5z equals 2650. So I have my 3 equations. So what is the matrix going to look like? Remember that in order to use a matrix, I have to have all my variables in standard form on the left-hand side and all my constants on the right-hand side. What I'm going to have to do is I'm going to have to manipulate a couple of these equations. This one is in standard form. I have x, y, z equals constant. So let's go ahead and look at this equation. So I need x, y, and z on the left-hand side, and if you notice, there is no x, so I'm going to make sure I have a 0 for that. I'm going to have to move z over here and move 10 over here. So let's go ahead and do that. Alright, so what I've done here is I added 10, so 10 is positive, and I subtracted z, so I have y minus z, and I moved it over because I have 0 x's. You could put a 0x there, or I just set it up with nothing there. It doesn't matter. Alright, so now I have to look at this one, x equals 3y. So I need all my variables on the left-hand side in standard form, and I need all my constants on the other side. So right now, I just need to subtract that 3y, and it's going to be equal to 0. So let's rewrite that. Alright, so I ended up with x minus 3y equals 0. I could put 0 in for z here, that's fine, or I could have 0 in here for here. But now I have my matrix. So matrix A is going to look like 1, negative 3, 0. Matrix B, the second row is going to be 0, 1, negative 1, and then 15, 40, and 5. And essentially what I'm doing is I have the variables. So I'm taking each one of these terms in the matrix, 1x, negative 3x, 0x, and that is equaling matrix B, which is going to be 0, 10, and 26, 50. So this is what's happening with our matrices, is we're saying matrix A is the coefficients that get multiplied by the variable, and this is what they equal. So 0 y's, 1 y, negative y gives me 10. 15 z's, 40 z's, and 5 z's give me 2650. And so when you think about, I have number times variable equals this, well, how do I undo that multiplication? I would divide. And so that's why when we're putting it in the matrix, we say A inverse, because that's the division. I'm taking the opposite of it. And we're going to take that inverse times B. That's why we're typing that in, because we're taking the inverse of A and multiplying it by B, which is essentially how we find out what X, Y, and Z are. So go ahead and pause the video and put those variables into your calculator. Alright, so when I put everything in, I ended up with the on-site costing 90, the at-store costing 30, and the by-mail costing 20, which makes sense. The on-site is 3 times as much as the at-store. So on-site is 3 times at-store. The by-mail is $10 less than at-store. So at-store is 20, and the mail-in, the at-store is 30, and the mail-in is 20, which is 10 less. And then if I took 15 times 90, 40 times 30, and 5 times 20, I would get $2,650. All right, so I would like you to try this problem on your own. I want you to start with the first 3 questions. So what's my question asking? What are my variables? Defining those variables. And then what equations can I write? So go ahead and do that now. All right, so they actually told us to use A, K, and N respectively. If you used X, Y, and Z, that's fine. But A is Amy's age, K is Karen's age, and N is Nolan's age. So I know they've lived a total of 22 years combined. Combined means adding. So Amy's age plus Karen's age plus Nolan's age is 22. Karen is twice as old as Amy, essentially. So Karen has to be older. So for Amy to catch up, I have to say that Karen equals twice Amy's age. And then Nolan is 6 years older than Amy. So Nolan is older. So for them to be equal, I have to take Amy and add 6. All right, so now let's make sure that we put these in standard form so I can put them in the matrix. So go ahead and rewrite this equation and this equation, because this is already in standard form, to get them all lined up, ready to go in the matrix. All right, so this one I needed to move the 2a over, so I subtracted it. So negative 2a plus k, I don't have Nolan's age in there, equals 0, because if I subtract this, I'm left with 0. And then over here I subtracted a, so minus a, there's no k, plus that n equals 6. So now I'm ready to put it in my matrix. So my matrix A is going to be 1, 1, 1, because I have 1, 1, and 1, negative 2, 1, and 0 n's, and then negative 1, 0 k's, and 1 n. And then my matrix B is going to be 22, 0, and 6. So go ahead and see if you can find the ages of these children. So hopefully you came up with Amy is 4, Karen is 8, and Nolan is 10. And I can always double check. I know that all 3 of them have 22 years together, so 4 plus 8 plus 10 is 22. I know that Karen is twice as old as Amy. So Karen's 8, Amy's 4. That is twice as old. And I know that Nolan is 6 years older than Amy. So Amy's 4, Nolan is 10. That is true. All right, so our first objective is solving a system of 3 linear equations. So we've looked at 3 different examples. Go ahead and look through these sub-objectives, identify where you're doing okay, where you're lost, and have an interaction. So in your notes, you're identifying what are things you need to remember, what is new learning for you, what questions do you have, where do you need me to explain things or talk to your CSG group about. All right, so in this problem, Lacey is speeding in her car and sees a parked police car on the side of the road right next to her at t equals 0 seconds. So right as she passes him, that's when time starts. She immediately decelerates, so that means that she's slowing down, so the graph is going to go down, but the police car accelerates to catch up with her, so they're going in that same direction. The distance that Lacey has traveled in feet after t seconds can be modeled by this equation. So the nice thing is they already give me the equation right here. That's going to represent her. The distance that the police car travels after t seconds can be modeled by this. And so how long will it take for the police car to catch up to Lacey? So I'm looking for when they're going to be the same. So when the distance, because if you notice, the output is distance, the input is time. So at what time, how long, at what time will their distances be the same, meaning that they're equal? So I'm going to use my calculator. I'm going to go to that y equals function, and I'm going to put this and this in. And what that will allow me to do is graph it and find the intersection. So if you need help with that, scan the QR code and watch my calculator steps. But to solve this, I'm going to put this function into one y equals and this function into the other y equals, and I'm looking for how long, so I'm looking for the time to be equal, and then I'm looking for how far, so I'm looking for the output at that time. All right, so it will take the police car 16.2 seconds to catch her, and it will happen at about 1,050.2 feet. So what this is saying on a graph, essentially, is if this is time and this is feet, so we've got Lucy and she's speeding, and then at t equals 0 seconds. So at the start of the story, she starts decelerating. So that's going to be an upside down quadratic because that a is negative. And then the police car is parked here, and he starts accelerating. So I'm looking for this point of intersection, and that's what my calculator can do for me. All right, on this one, you are saving for a new boat, and you decide to invest your money in TVA Bank, which offers 5% interest compounded annually. You deposit $2,500 in the bank, so I've got this equation right here. That represents that. My initial value, and this is the growth rate. And it's going to be your account balance, that's the output, after X years. So the boat you're saving for is worth $8,000, brand new. So that's the initial value when time is 0, and it's depreciating. So it's going down at a rate of 9% per year. So that is this right here, and X is the time. So as the time goes on, it's getting, the output or the cost of the boat is getting smaller. So when will you have enough money in your account to pay for the boat? So I'm looking for when my account and the boat cost are going to be equal. So when I think about what that looks like on a graph is we've got time, we've got the account, or the money or whatever, my account balance, the cost of the boat. And so the boat is starting up here higher than what I have in my account, and it's depreciating. So it's going down. The cost of it's going down. Whereas here, my money is lower than that, but it's appreciating because it is getting larger than 100%. So it's growing exponentially. They're giving me more money. So again, I'm looking for that point of intersection, and the question is when. So when I think about when, we're talking about time. So I'm going to use my calculator, and I'm going to put those two functions into the y equals, and I'm going to zoom fit and find that point, calculate that point of intersection. So if you need help with the calculator steps, watch the QR code that's off to the side. All right, so after about 8 years, I will have enough money in my account for the boat. It ended up being 8.12, so I said about 8 years. All right, so that was the second part of our objective, is to use your calculator to find that point of intersection and then explain what it means in context. So we have now done a system of 3 and a system of linear and nonlinear equations, solving them graphically, so looking for that point of intersection. All right, go ahead and have an interaction in your notes and organize what you want to bring to your CSG tomorrow.